Hello everyone, and welcome back to Reverse Engineering Linux 32-bit applications. In this video, we're going to continue our discussion of reversing malware, and in particular, we will talk about using GDB as a debugger. Now, in a previous video, we talked about how you could use Evans Debugger. Personally, I would recommend you use a tool like Evans Debugger for most people. However, I know that some people would prefer to use GDB just because it's built in. Maybe you want to use it for other things and you want to learn it a little better. Incidentally, there is a course at Pentester Academy all about GDB and how to use it. So if you're one of those people, I would definitely recommend you have a look at that course. All right, let's get started here. So I already have my virtual machine up and going. Let me full screen that. And of course, I'm running things in a virtual machine because I am a little bit concerned about what this malware might do to my normal box. So I have it in this little sandbox. And now I'm going to, instead of running EDB, I'm going to run GDB. And I don't want to run this one in the background because it's a command line tool. All right, so GDB has a little bit of a learning curve to it. Fortunately, it has really good help. So I can do things like help, and then it tells me what I can do from there. So a list of commands, I can get some aliases, breakpoints, etc., etc. So I can get various info from this. So if I typed help info, it will tell me what the info command can do. So I can get information on a whole bunch of things. Now, one thing that I want to do is I want to get information on all of the functions in my unknown executable. So I can go ahead and say, all right, info functions. Now, by the way that this tool works, as long as it's not ambiguous, I can shorten. So I can say info fun, and it gives me a list of functions that it found. So we have a init, and it's that boilerplate code that it's going to start with. We have some calls to our various library functions. Again, if it has @plt, that's an external function that's being called. Here I see start. That's the beginning of my program. And then a couple of other functions as well. So that is how I can get a list of functions in my executable. So what are some other things that I might want to do? I might want to disassemble a certain function. Let's start with the main. I can type disassemble. And again, if it's not ambiguous, I can shorten it. I can also use tab completion if I prefer. If I'm concerned that maybe I can't shorten. So I'm going to disassemble main. And now it will show me my disassembly. Now, some of you might be looking at this right now going, seems a little strange. Not exactly the assembly that I'm used to. Going to hit Q, and I'm going to show you how to change that. So what I have to do is I have to set a variable. So I'm going to call set disassembly flavor to Intel. And now I'm going to rerun my command. Notice I'm able to hit the up arrow and I have command history in GDB. And now it looks closer to what I'm used to. So I have the Intel flavor of disassembly. If I want to create a breakpoint, let's say I want to create a breakpoint at the start of main, I can give it an address. I can also give it a function name. So I'll hit Q here and I'll just say break. And I will say break main. And it says breakpoint 1 at this address at the very start of main. Now, if I want to run to my breakpoint, I just type run and I hit my breakpoint. From here, I can step and it will step through my code. I can also use step I. Step I will run the next assembly instruction and it will step over any function calls. So I can do that. I can also type continue, which will run to my next breakpoint, which in this case I don't have one. So it's not going to do what I want. So those are some of the basics of how to use GDB. And of course, I can get a list of my breakpoints. If I choose. I want to get some info on breakpoints. And it says, here's my breakpoint. I already hit it one time. As I go, I can get information on my registers. So I can check my registers as I'm running. And I can also use the examine command in order to look at registers or memory areas as I choose. So how does that work? I could do something such as this. I could say, I would like to look at the first 28 byte values on my stack. So the command is X for examine /20. I would like to do this 20 times. I would like to display in hex giant values. And here's what I would like to display. $RSP. That's my stack pointer. Recall we briefly mentioned this. We said if you're talking about a 64-bit executable, then instead of ESP, we have RSP, etc. And there you have it. So these are the top 28 byte values for my stack. And of course, there are other ways I could display that. I don't have to just restrict myself to the stack. I could use any address if I so choose. For example, maybe I want to show a certain region, and I might use a command such as this. I could say, please examine as a string what's pointed to by the hex value 6010D0. And it says, wait, I can't access that memory location. Which is not terribly surprising since I just randomly picked something. And it tells me, hey, that's an incomplete sequence. Okay, so let's have a look at this main again. So I'm going to do a disassembly of main. And I want to see what I'm pointing at here. So I will continue. And what I'm looking for is a particular function call. And let's see if we can find it. So I'm looking for a call. And here it is. I see bind shell password. So I'm going to go ahead and quit. And I'm going to examine as a string star 0x602148. And it says what's stored there is in fact this password, which we discovered earlier when we looked at this. So when we looked at this with strings, we found this password swordman, and here we have it again. So another way that we are able to find this out. All right, so that is how I can use GDB instead of EDB. And again, if you want to go this route, maybe you just love command line stuff. Normally I like command line stuff, but I'll be honest, I greatly prefer a tool like EDB over GDB for things like this. Again, GDB was intended primarily to debug programs that you wrote and have source code for, and it wasn't intended so much as a tool for reverse engineers. There are some graphical front ends for GDB that you can get out there. So I wouldn't discourage you from finding those and using them if that's what you choose to do. But, Evans Debugger is probably a better choice for most people. And again, if you do go this route, please have a look at the GDB class here at Pen Tester Academy. Okay. Well, this brings us to the end of what I wanted to talk about in this particular video. As a reminder, this video is one in a whole family of videos that we have here at Pen Tester Academy, your source for everything InfoSec. And I look forward to seeing you in this course or another course soon. See you then.